Hello, greetings. I hope you are doing well. So today we are in the next part of calculus, that is under integration. So today, before I continue, if you are new to the topic, please feel free to follow my previous videos. And also, if you are new to the channel, please subscribe and help me to grow more audience. Now, today we are looking at this part, that is the diagrammatic. That is diagrammatic sorry. Yeah, we are looking at the diagrammatic integration and differentiation. Diagrammatic integration and differentiation differentiation. So this is what we shall look up to the end of our lesson today. This is what we are mainly going to discuss. Now, under integration, the exact area under a graph is found through integration. I want you to note this. Note. The exact area under a graph is found through integration. The exact area under a graph is found through integration. Make sure you underline the exact area. Underline the exact area, then underline integration. Those are the keywords there. So, example 1. Let us start with example 1. Example 1, we shall look at a one full graph. That is one full graph. Or one body. So, for example, calculate the area of the shaded figure below. Calculate the area of the shaded figure below. Then a Cartesian is drawn. Then the function or the curve is provided to something like this. Then the shaded part, here we have 0. This is y, x, y. So the function is given as y equals to x squared minus 2.5x minus 1.5. Then the curve cuts the x-axis at 3. Sorry, let me indicate it well. So it cut at exactly this point, there at 3. Then this other point at negative 0.5. Then the shaded area or the shaded part is this one here. Let me shade it with another color. This is the shaded part. Now, we are integrating. Remember, I've told you that, okay, the question read that calculate the area of the shaded figure below. If you look at this thing keenly, This is a one body. This is a one body or a one full graph, the curve itself. So we are integrating. So to integrate, you start from a smaller value moving to a bigger value. Start from a smaller value moving to a bigger value. So we shall integrate this one as we start from negative 0.5 integrated. What are we integrating? X squared minus 2.5x minus 1.5 dx, then through 3. So this is what we have. So upon integrating x squared minus 2.5x minus 1.5, we shall have a third x cube minus 1.25x squared minus 2.5x squared minus 1.5. Then these values, the negative 0.5 and the 3, they will now be written at this other far end of after the graph. That one will now be negative 0.5 all the way to 3. So we integrate by substituting to get the actual value or the actual area under the graph. Now starting with 3, we start with 3. So we shall have remember, there is a difference. Whenever you are integrating, you must get a difference. So because of my space, let me write it neatly. So we shall start with a third into 3 cubed minus 1.25 into 3 squared. Sorry, this point was x. This one was x. 1.5x. Yeah. Minus 1.5 into bracket 3. Then you press this in your calculator. You will get negative 6.75. Now you come and do the same to negative 0.5. So we are having now a third into negative 0.5 cubed, minus 1.25 into negative 0.5 squared minus 1.5 into negative 0.5. Press this in your calculator. You will have 19 over 48. 19. Avoid the decimal. If the answer can be expressed in fraction, avoid the decimal if the answer can be expressed in fraction. Now, after having this, you get the difference. You get the difference. So remember, it will be now negative 6.75, subtract to 19 all over 48. 19 all over 48. Doing this, you will get a negative 7 all over 48. Negative 7 all over 48. Now, I want you to note this. When calculating areas in graph, using integration, a negative value for area means that the graph is under or is below the x-axis. The graph is below the x-axis when the area is found to be negative. Like in this case, our final answer is negative 7 over 48. That means that this curve is below the x-axis. Sometimes, in most of the questions you will interact with, an examiner will not draw for you a graph. Rather, you will be just provided with the equation or the explanation in a details form. A graph will not be drawn for you. So in some cases, you must know that a negative area when integrating, that means that that area or maybe that graph is below the x-axis. So that means our answer, we usually ignore the negative because an area cannot be negative. Area cannot be negative. So we usually ignore the negative. And now, therefore, you come and complete your answer to be now, therefore, our area will be 7 all over 48 units squared. Units squared. Do not forget the units. Do not forget the units. That is example 1. And example 1 is one full body. One full body. Or what? Or one full graph. That is our example 1. Example 2. Example 2. Example 2. Example 2. Example 2, we are looking at two bodies under a Cartesian plane. Two bodies under a Cartesian plane. Under a Cartesian. How is Cartesian written? Cartesian. Under a Cartesian plane. A Cartesian plane. That is example 2. Now, note this. You cannot integrate two bodies at the same time. You cannot integrate two bodies at the same time. I want you to note it. NB, write it somewhere. You cannot integrate. You cannot integrate two bodies at the same time. At the same time. You cannot. So, example we shall use in this place. Calculate the area under the figure below. Calculate the area under the figure below. Now, a Cartesian will be drawn. Y, X. Then a body runs in this manner. You will excuse me, please, because I don't know. But let me try drawing the graph in it. Yeah, something like this. When you see something like this, this is a two-body. This is a two-body graph. We have the first body here. And we have the second body at this one. So there are two. But remember, they share the same function. So this is what we have. So like, for example, let me assume that the curve cuts x-axis at this point. Let me have it maybe at negative a. The other point at maybe b, and the other point at maybe c. So let me talk of something like that. Then we have our function. The function could be something like, let me just guess, y equals to x squared minus 9x plus 10. Something like this. Okay. Now, suppose a graph looks like the one above or this one. Suppose our graph or the graph you came across in equation looks similar like this one, then in that case, the two faces cannot be integrated at the same time. There is a procedure. There's a procedure of getting area of two bodies. There's a procedure. So, what is that procedure? When you are integrating this is the procedure. You will integrate from the first body you put aside, then the second body also you put aside. So you will integrate this way. You'll integrate from negative a, and what are you integrating? You are integrating x squared minus 9x plus 10 dx all the way to b. That is the first one. Plus, then you add, remember there are two bodies, so plus the second body. Now the second body also you pick it from the minimum, which is from b. The same function is being integrated, x squared minus 9x plus 10 dx all the way to c. Now this is what you should do when you are integrating. This is what you should do when you are integrating. Let me tell you. Maybe I know someone could be wondering, why am I using dx? Why should I put dx there? Now, dx in this case means, when used like this, dx means reading values of x, reading values of x axis. Dx means reading values of x. That just simple like that. That means that the values we'll be using to get the actual area will be coming from the x line or the x lane. Okay, I want you to note again, note. Sometimes, not in all cases, but sometimes the values of either negative a, b, and c. Remember, I just gave an example. These were just an examples that I gave. Negative a, b, and c as maybe where the curve could be cutting the x-axis. Sometimes an examiner will not provide you with the actual values. An examiner will not provide you with the actual values of negative a, b, and c. An examiner will not do that. So in a case that examiner has not provided you with those values, you can get them. You can still get those values, and you will apply the knowledge of x-intercept, and sometimes it can land you to quadratic. What do I mean by the application of the x-intercept? We always say at x-intercept, y is equal to 0. Now suppose, I don't know why I like using suppose, but that is it. Okay, in case an examiner gave you a function like this, without providing the values of negative a, b, and c, without giving you the actual values of negative a, b, and c, then you will apply the knowledge of x-intercept, and that knowledge always terms as at x-intercept, y is equal to 0. So that is the same thing you will use. Now, you'll come here and say at x-intercept, y is equal to 0. At x-intercept, y is equal to 0. That means you shall have x squared minus 9x plus 10 is equal to 0. And by doing this or solving this, you will get the actual values of the x-intercept that cuts across the graph. that cuts across the graph. That is that. Now to get answer, you integrate each phase at a time and later add them together. This one will be a very long work. Integrating this one will be a very long work, very long. So you have to minimize your handwriting if your handwritings are always big, and you have to be keen. You have to be keen, because you integrate this, then you get the difference, put aside. Come and integrate this, get the difference, put aside. Then later now add them together. That one will be the final answer. That one will be the final answer. Example 3. Example 3. Example 3. Let's look at example 3. Example 3. Example 3 is a irregular curve. I'll call it something like irregular curve. Though this one is rarely tested in exam, but when you are going to what? It's called what? The contest, mathematics contest, you must meet it. It is called the irregular curve. You know, those contests contain very brave students. So easy things will never be tested in that contest. So example 3, we are having irregular curve, and irregular curve, this one always appear at a y-axis. Have you ever seen a graph that appears at y-axis alone? So that is what we are discussing here. Listen, these type of curves, they do not cross or they do not cut the x-axis. These type of curves do not cut through the x-axis. They don't. Example. A Cartesian plane will be drawn. Let me draw it reasonable in a way that I will get okay. A Cartesian plane will be drawn. Then something like this will be, sorry. It is not easy to use a machine explaining this, but just understand me. Something like this. Then we are having that part and that part. Then the shaded part is this one. This part is shaded. This part is shaded. This part. So the examiner asks you that, okay, let me give this a function, maybe like y is equal to x squared. Y is equal to x squared. You will be given something like this. Y is equal to x squared. Now, these curves are curves under irregular curve. These curves are like games. The game, any game that you know, that is mathematics. Mathematics is a game. Now, these curves, they're like games. If you are keen all along with me, the curves that cut along x-axis, were equated to y. The curves that cut x-axis were equated to y. So, what if y-axis. What if the curve now cuts the y-axis? Opposite. Opposite. You do the opposite. You do the opposite. Only equate it to y, or make y the subject of the formula. Opposite. You make y the subject of the formula. You make y the subject of the formula. Okay, how do I do that? Now you modify. So modify, if I take you back to this, whatever we were doing here, you will realize that these curves are equated to y. All curves that are cutting the x-axis are equated to y, y. And now the examiner, this kind of question requires a very good student. Examiner will not give you direct things. Examiner has equated this curve with y, making y the subject of the formula, y equal to x squared. But it should not be like that. It should not be like that. Examiner will make the y subject of the formula already. The examiner has made y the subject of the formula already. For you as a student, you must now change x to be now the subject of the formula. You must change x to be the subject of the formula. How do you do that? You modify the function given. You modify the function given. Now like this case, an examiner gave us y is equal to x squared. Y is equal to, how do I make x the subject of the formula? Get the root on both sides. So that means this root will cancel the square. So that means my x will be equal to root y. Root y can also be expressed. You must do a deep revision. Remember, if you just leave your answer like this, it will not make sense as a smart student trying to navigate a difficult question in mathematics. You must not leave your answer in this format. Rather, if I were you, then my answer would be x equals to y power a half, which is the same thing. It is not wrong. It is not wrong to leave your answer in this format. But it is advisable to simplify your answer to something more reasonable. So that is that. So in that case, you make x the subject of the formula. X, now our x will be y equal to y power a half. Y power a half. That means when we will be integrating, we will be reading the values. Like for example, let me just name here to be a and here to be b. Let me name here to be a, that to be b. So we will integrate our curve from a to what are we integrating? We are integrating y power a half dy. Now you don't put dx because the values you will be obtaining, that is a and b, will be from the y-axis. So here we are integrating y power half dy through all the way to b. So this is what you should do, guys. That means a obviously is the minimum. A is the minimum value possible and b is the maximum value possible provided. This term doesn't mean anything great. What I mean just whenever you are integrating, pick a smaller value you must start from a smaller value to a larger value. And that is what I'm doing in this case. I'll pick from A to B. Okay, so that is that, guys. I want you to note this. Note NB. Write NB. Positive and positive. And now, this one is more like an explanation. This one is more like an explanation, trying to give some details. Now, just listen. Positive and positive cannot attract. You know that one from the law of physics, maybe. Positive and positive cannot attract. Same to negative and negative. Negative and negative cannot attract, them to positive and positive. But negative and positive react. They can attract. That is why, not why, that is why y is equal to y is unsolvable. That is why y is equal to y is unsolvable. And the same, and y is always equated to x. Y is always equated to x for that kind of an answer to be solved, or for that kind of equation to be solved. Okay? Let us look at the last part of this diagrammatic integration. Example 4. Example 4. Example 4. The act, now listen. Listen. I want you to listen. This act of subtracting a function or a line from a line or a function is usually to calculate the area of unshaded region. You will understand if you stick with me, if you follow me, and if you pay attention. Remember, develop the interest. Have that positive energy toward mathematics, even if still you can't understand something. Please, listen. This act of subtracting a function or a line from a line or a function is usually to calculate the area of unshaded region. Sometimes we might be required to find the area that is not enclosed by the x-axis. Sometimes we might be required to find the area that is not enclosed by the x-axis. Remember when we integrate a function, we are obtaining the area of all space. Remember when we integrate a function, we are obtaining the area of all space. That one takes us back to example number 1, where we started at first. Remember when I integrated this value, or this curve, sorry, when I integrated this curve, I was obtaining the whole area of the shaded part in red. Okay? That one has something to do with what I want to tell you in example 4. Now, a Cartesian plane is drawn. A Cartesian plane is drawn, something like this. Something like this. Then we are having that one. Then there's a line. There's a line cutting it across that way. There's a line cutting it that way. Then this part is shaded in green. We have this part shaded in this color green. We have that one. Then we have the remaining part. Not the remaining, but now the whole part. I don't know which color should I use. Maybe let me try yellow. Now, the whole, okay, let me use red. Let me use red, will be more clear. The whole curve. Let me shade the whole curve. There's something I want to talk about. There's something I want to tell you. Now, if you're keen, we have two shapes. We have the whole shape shaded in red, and we have a section of the curve shaded in blue. Are we understanding one another? The whole curve is shaded in red. Then a section or a part of it is shaded in green. That means, now get me. When we are integrating, we are getting the area of all this curve. That is the part shaded in red. Now, sometimes an examiner will want you to only get the area that is a part of that whole curve. Example of this section that I've drawn, the part covered in blue. An examiner will want you to get only the area of that part covered in blue. What will you do in that case? Now, suppose this function is given by a y is equal to 6 plus 3x minus 2x squared Suppose we integrate the curve. The function we obtain all the area. Okay. I don't know if you are getting me, but let me just continue. But I request, if you are not getting me, feel free to always drop a comment that I've not understood this lesson. I'll be free to teach. I'll be free to spare some of my time to make you understand. Now, suppose we integrate this curve. The area we will get will be for the whole curve. That is the part shaded in red color. Okay. But normally an examiner will give you the function of that curve and also provide you with the function of the line. Now, for example, the function of this line is maybe something like 3 minus 2x. I want you to note. That means to obtain the area of the part shaded, that is the green part, to obtain the portion or the part of the whole curve, we subtract the function from the equation of the line regarding who is the top. Like in this case, who is at the top? Obviously, it is the function. Sometimes a Cartesian plane will be this and the line cuts across this way. What is at the top in this case? It is the line. What is below it? The curve or the function itself. That is why I'm telling you that for you to obtain the area shaded, we subtract the function. The curve is always the function from the equation of line regarding who is at the top. That marks the end of our lesson, guys. Thank you very much for following and for sticking with me. Thank you very much. And in the next video that I'll do, we shall now look at more question of what I'm trying to explain to you here. We shall look at more question involving whatever I've discussed in this part. I know you don't want to miss that section. If you are new to the topic or new to the channel, now first, if you are new to the topic, feel free to check the previous videos, and if you are new to the channel, please subscribe and invite other friends. Otherwise, I thank you very much. If you have understood this lesson, feel free to give a like for this video. Thank you very much. Have a good day.